Imagine a developer at the end of a long day pushing a quick fix and hard coding an API key just for now. That code gets merged, cloned to dozens of laptops, copied into mirrors and forks, and maybe even into a public repository. At that point, the secret is no longer a secret at all, even though nothing seemed dramatic when it was committed. This is the quiet, everyday way many incidents begin. In this narration, part of the Tuesday Insights feature from Bare Metal Cyber Magazine and developed by Bare Metal Cyber, we are going to slow down and really explore the problem of secrets in source code, what that phrase actually means, and how to build healthier habits around it.
When we talk about secrets in source code, we are talking about any sensitive value that ends up directly inside code, configuration files, or related artifacts in a way that ordinary users and developers can read, copy, and share without special protection. These values are usually credentials or keys that grant access to something valuable, such as a database, a cloud account, a payment gateway, or an internal microservice. The risk is amplified because source code tends to spread widely as people clone, branch, and back up repositories, which means any secret tucked inside tends to spread right along with it and then persist for a very long time.
Secrets in code sit at the intersection of secure coding practices, identity and access management, and secrets management. They are not just a developer problem or a DevOps problem, but a shared concern that shows up anywhere teams are building, testing, and deploying software. That includes small command line scripts, infrastructure as code templates, and large multi-service platforms. The blast radius of a leaked secret is tied to how broadly that code is shared, where it is stored, and how easily it can be copied outside the organization's control. Examples help make this concrete. Think about database usernames and passwords, cloud provider access keys, private SSH keys, API tokens for third-party services, and long-lived session or signing keys. All of these are secrets when they can be used to gain access, impersonate a service, or read sensitive data. Even sample data or test credentials can be risky if they work in non-production environments that attackers can pivot through. On the other hand, non-sensitive feature flags or generic configuration values usually are not secrets, even though they live in the same files, which is why teams need a shared understanding of what qualifies as sensitive.
A common and dangerous misunderstanding is the idea that private repositories are safe places to store secrets. The word private creates a false sense of comfort. In practice, a secret in a private repository is still copied to every clone, cached in backups, and often accessible to people with broader platform access than you expect. The code hosting platform silently becomes part of the secret storage system, whether anyone intended that or not. Recognizing that your repositories function as one of your biggest distribution channels is often the moment when teams start treating secrets in code as a systemic risk rather than a rare accident.
In real environments, dealing with secrets in source code is less about finding one magic tool and more about how several building blocks work together in a predictable way. Most teams rely on a detection engine that looks for patterns, such as known API key formats, high entropy strings that resemble keys, and custom rules tuned for their own services and integrations. That engine can run at different points in the development lifecycle, including on developer laptops before commits, inside continuous integration and delivery pipelines, and as a periodic background scan across all repositories.
A typical flow might look like this. A developer adds a new integration and accidentally commits a secret. A pre-commit hook or local scanner runs and issues a clear warning before the commit completes. If the secret slips through, a scan in the pipeline flags the issue, fails the build, and creates a finding for the team to review. Once someone confirms that the value is a real secret, the underlying system is updated so that the secret is rotated. The application is changed to load that value from a secrets manager instead of hard-coded text, and the committed secret is removed from the current code and, where feasible, from history.
Logging and notifications throughout this process make sure the right people know what happened and what was done.
As programs mature, teams add organization-wide scans that sweep both current branches and older history to catch long-buried secrets. These broader runs often produce a backlog of findings that must be reviewed, prioritized, and either fixed or formally accepted. That review process depends on several assumptions, such as being able to rotate the underlying secrets, having clear ownership for each system, having enough logging to confirm whether a secret was abused, and having leadership alignment on how strict build failures should be. When those assumptions are not met, technical scanners can still flag issues, but the overall experience will feel noisy and frustrating.
Exception handling is another small but important detail. Some values look like secrets, but are not actually sensitive, or carry low enough risk that immediate work is not justified. Teams sometimes need to accept these cases temporarily, but doing that informally erodes trust in the tools. Strong workflows make it easy to mark exceptions in a controlled way, with audit trails, time limits, and approvals, instead of encouraging developers to disable checks whenever they get in the way. That discipline helps keep scanning effective and credible.
Once the basics are in place, secret scanning becomes part of everyday engineering hygiene rather than a one-time cleanup project. Many teams treat scanning as a standard gate for new or critical repositories, ensuring that any new service, infrastructure as code project, or shared library starts life with scanning enabled. They also schedule recurring scans of older repositories, particularly those created before formal security practices were in place, to find legacy credentials nobody remembers committing. These scheduled runs often uncover surprising numbers of keys and tokens hiding in old branches and tags.
Secret scanning supports a range of recurring situations that teams quickly learn to recognize. For example, anytime there is suspicion of a compromised laptop, lost device, or misused account, a focused scan of relevant repositories can reveal whether secrets were committed during the risky period. After onboarding a new vendor integration or cloud account, scanning helps confirm that the integration did not leave stray keys lying around in sample code or tests. When red teams or bug bounty researchers report exposed secrets, scanning can validate that every related repository and branch has been cleaned up, not just the obvious one. For smaller or resource-limited teams, realistic, quick wins matter more than large, complex rollouts. One effective first step is enabling built-in secret scanning in the main code hosting platform for a handful of high-value repositories, and enforcing a simple rule that pull requests with open secret findings must be reviewed before merging. That single change can block a large class of mistakes without requiring a full program. Another approachable win is running a one-time amnesty scan on a flagship application, paired with an explicit offer of help for developers who discover secrets and need support rotating them safely.
More advanced programs tie secret scanning into central secrets management, identity systems, and inventories of critical services. In those environments, a single finding can create an automatic ticket linked to a known system owner, trigger a predefined rotation playbook, and update the risk register. Over time, leadership can watch trend lines for the number of new leaks, the speed of secret rotation, and the consistency of ownership across teams. That shift from ad hoc reactions to structured, measurable behavior is a sign that secret management is no longer an occasional project, but an integrated part of how software is designed and shipped. When teams invest in handling secrets in source code, the first and most visible payoff is straightforward. There are fewer accidental keys, tokens, and passwords leaking into locations attackers can reach. Secret scanning and improved handling practices shrink the amount of time a leaked secret remains active, which directly reduces the window in which someone can discover and exploit it. That difference in timing can spell the difference between an internal cleanup and a public incident with regulatory scrutiny and reputational damage.
There are also deeper, less visible benefits that accumulate over time. Defining how secrets are supposed to be managed forces teams to map which systems exist, who owns them, and where credentials actually live. That mapping feeds broader risk management, compliance reporting, and incident response. Developers gradually learn that the default pattern should be to pull secrets from a central manager and configuration system, rather than leaving them hard-coded. The organization develops muscle memory around rotating and revoking access whenever something seems off.
The trade-offs are genuine and are worth being honest about. Rolling out secret scanning and better handling practices takes time, tuning, and cultural change. Teams must configure tools, define custom rules, and be willing to adjust these over time. Without that investment, false positives and noisy alerts can sour developers on the whole idea. There are also clear limits to what scanning can do. It can check many kinds of repositories and catch many patterns of secrets, but it cannot prove that a leaked key was never used, and it cannot replace carefully designed access controls, least privilege, and high-quality logging. Secret management programs often fail for reasons that have little to do with the scanning technology itself. One common failure mode is tool installed, process unchanged. In that situation, scans produce long lists of findings, but nobody clearly owns them, and no one has the authority or time to rotate the underlying secrets. Developers learn that alerts do not lead to action and gradually ignore them. Another failure mode is treating secrets as purely a security team concern, which leaves security staff trying to clean up leaks without the context or access needed to make lasting changes. Shallow adoption also shows up when secret rotation is painful or slow. If changing a leaked database password requires weeks of coordination and risky manual changes, teams will become reluctant to trigger that process. That reluctance can lead to quiet exceptions, informal overrides, and eventually to people disabling or bypassing scanning in order to meet deadlines. Over time, the tool becomes background noise rather than a protective control, and secrets continue to move through code and history in unsafe ways. Healthy programs look different at a practical, day-to-day level. Developers expect secret scanning as part of their normal workflow and see clear, understandable messages when something is flagged. For each type of secret, there is a known owner and a documented rotation path, so findings become concrete tasks instead of vague security debt. Teams rely on a central secrets manager and configuration system, so the normal pattern in code is to reference a secret by name rather than to paste the raw value. Metrics help tell the story, including fewer new leaks over time, quicker closure of findings, and clearer evidence during incidents about what was exposed and how it was handled. At its heart, the problem of secrets in source code is about understanding that repositories are one of the largest distribution systems in any modern organization, and anything placed inside them will travel farther and live longer than most people assume. When teams treat secrets as first-class assets with clear ownership, storage, and rotation paths, source code becomes a consumer of secrets instead of an accidental vault. Secret scanning, central management, and well-designed workflows all reinforce that mental model.
For security and IT professionals, this perspective offers a practical way to look at existing environments. You can map where code lives, how it moves, and who can copy it. Then think deliberately about how many sensitive values are likely riding along. If you can steadily reduce the number of places secrets appear in plain text and shorten the time between detection and rotation when they do leak, you are already making your organization a harder target at one of its most common weak points. That steady, practical progress is what turns the idea of secrets in source code from a worrying phrase into a manageable, well-understood risk.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.